Good morning, everyone. Welcome to the C&E Sales monthly webinar series. My name is Tony Belter. I'm the Vision Product Specialist here at C&E Sales, and today I want to talk about the Teledyne DALSA GEVA 300 system. This system has been out for just about a year now, and it's the next evolution in DALSA's multi-camera vision offering. As you see from this picture here, this is the GEVA PC. It is a PC-based system. This box is a solid-state PC, fanless configuration. And let me go to slide view for you. And here's some of the specs of the GEVA 300. It does run a dual-core Atom processor. And I'm not going to read all these things for you, but I just want to point out a few items on here. It does have 6 GigE Ethernet ports on it, but for each one of these systems, you're only going to use 4 cameras per GEVA 300. You have 2 extra LAN ports in case you want to tie it into other devices on the factory floor or tie it into your factory network. There are 3 USB ports on here. It does have an RS-232 port, and I'd like to remind everybody that it really looks like an RJ45, but it is the 232 port. You have a VGA port, and it is running Windows 7 embedded. To use this system, and I'll have a drawing of a system configuration here in just a little bit. It's a PC, so what you do is after you mount this and you connect everything up to it, you're going to hook a monitor through the VGA and a mouse and a keyboard through one of the 3 USB ports, and you're going to use it just like you would a PC for programming. The software is embedded in the system when you get it, and you can order it with either the iInspect Express software or the Sherlock software, which we're not going to cover here today, or both. You could have both on there. One thing I want to point out here too is it is a 12-volt DC system, and the unit will be shipped with a 24-volt DC to 12-volt DC converter. And one of the reasons that we have to use this converter is the cameras are actually 24 volts DC, and we want to keep them all on the same ground from the power supply. So we want to use one power supply to supply the 24 volts to the camera heads themselves, and we run through this converter to supply the unit with 12 volt DC. And there are options for DIN rail mounting this. This is the front view of the system, and here we've got the VGA and one of the USB ports and the power connection. There is a reset button on here if you need to reset this system. When you apply power to it, it boots. There is no really on-off switch. You could use the reset. This is the business side of it. This is where we have the 6 GigE Ethernet ports. You have 2 additional USB ports, and that one label number 1 there where it says console, that is actually an RS-232 port. This is an option for using the GEVA 300, and it's called the PL-USB breakout board. It's not necessary, but it really makes connecting everything together a lot more simpler. And so as you can see across the top here, we've got cameras 0, 1, 2, and 3. This is where the cameras will receive their power from. We're going to apply power to this board, 24 volt DC, down in the lower right hand corner where it says ground power earth. And the cameras each have individual inputs and outputs in them, so they can be used in an asynchronous mode independent of each other, or they can be used in a synchronous mode, and I'll get into that in the next few slides. And then down at the bottom of this board we have access to all the I/O that's actually based in the camera, and there is a small USB 2.0 B port on the left side here, which will connect over to one of the USBs on the GEVA 300 system itself. Again, this will become more evident when I get to some of the configuration slides. But that helps in triggering and other things like that between these systems. We use the Genie GigE cameras with the GEVA 300. These are cameras that DALSA actually manufactures. They can be used in a lot of different scenarios, but these are what we do use with the GEVA systems. Just to clarify, GEVA is an acronym for Gig Ethernet Vision Appliance. Teledyne DALSA has used the term Vision Appliance for a lot of their systems, and some of you may be familiar with some of their older systems like the VA20s, 21s, VA30s, VA40s. They worked all the way up to the VA60s. The VA60 has been replaced by the GEVA 1000, which is a higher-end system, and I really won't be discussing that here, but for more complicated applications that require extremely high-speed response times, the GEVA 1000 is an option, and it too uses these Genie cameras. There's a lot of models of Genie cameras. What I've done here in this chart is I've highlighted the ones that I use the most. A lot of these are redundant. They just have maybe a 90-degree mount to them, or most of them are CS mount. The ones that I use are CS mount, but they do have a C mount. I'm sorry, but they do have a CS mount option. So what I've done is I've highlighted the cameras that I use the most, and you can see the most important thing here is the different resolutions of these cameras that you can get. The standard 640 by 480. We do have a 1024 by 768. Right in the middle of this chart, you see I have in green highlighting the 1280 by 960. That seems to be, at least from our data, the most popular camera used with the GEVA 300. But we can get into higher resolutions all the way up to 1600 by 1200. Again, these are all grayscale models, monochrome cameras. We do have color models, lots of choices, and again, lots of resolutions that we use. Color applications realistically only take up about somewhere between 5 and 8% of all the overall vision applications that we look at. Color is just not as popular as grayscale. Grayscale still is the way to go for most vision applications. These grayscale cameras are 256 shades of gray. Humans normally see 50 shades of gray, so they are 5 times more sensitive than we are, and for many industrial applications, monochrome works just fine. This image really is to emphasize the connections on the back of the camera. There are two connections to the back of the Genie cameras. One is for power and I/O, and one is for the Ethernet connections. And here you can see that in the upper right-hand corner, the RJ45 Ethernet connection to these Genies is also supplied with some lockdown screws. So once you put this in here, you don't have to be concerned about pulling that camera or that cable out of the camera. And then this chart just shows the different things that we're wiring to in the camera. For the most part, it doesn't mean much to us. We just put the wires on the proper terminals, and we kind of forget about this side of things. On another portion of the PL USB, we can wire to the input and output sides to monitor the inspection that we're going to do. And the point I'm trying to make here is, depending on how you wire it, your inputs and your outputs can be wired to be either PNP or NPN. These are open collector, open emitter transistors in here, and so depending on how we wire it, we can either do sink or source. There are some standard Ethernet LED indicators on here to determine whether we're using at 100 megabit or 1 gig. All these GigE cameras obviously are going to be at 1 gig, but we can operate at slower traffic if we have different cameras that you may want to use with the system. Now here's what the overall configuration looks like. So we've got the solid-state PC, the GEVA 300. We're going to tie up to 4 cameras into its Ethernet ports. When this unit ships, they are all shipped with different IP configurations in these ports, so that when you pull this out of the box and you pull your Genie out and start connecting it, they're going to be just about ready to go. We are going to have, now Genie cameras are all shipped with the same IP address, so one of them is probably going to connect right away, but the other 3 we're going to have to go in and modify the IP slightly in order to get good connection with this. But here you can see that we have the USB cable going from the GEVA down to the PL USB, which provides some interconnecting traffic. Then we've got the two cables coming out of the Genie cameras. The Ethernet cables are in green here, and in the black are the power and I/O cables that go into the PL. At the bottom of that PL is where you would interface this to your PLC or whatever other control structure you would have in there. When you get the GEVA and you first get into it, it's preloaded with its software, and it has several other utility software packages on there. And one of them is the camera and language selector. This is really a holdover from the Vision appliance years, where the old VA20s and 30s and 40s and so forth were using analog cameras, RS-170 signals. And so you could go in here and you could pick the different models of camera that you wanted to connect to the appliance. In our situation, if you look down here towards the bottom of this box, you'll see that I have checked, the radio button I have checked is GigE cameras, and that's really all you have to do here. The other features in here are up on the upper right-hand side, and we do have a box for Enable Recycle for iInspect. Recycle is an additional check. Normally when you set up your pass-fail parameters, you set a minimum and a maximum. So you've got your standard value in the middle, which they call perfect. And then to the left you'll have a fail, which is a minimum fail, and to the right you have a maximum fail. So you can set your window up on your tolerances. They also offer recycle boxes in there for certain customers that if they don't fall within inside a set of type parameters, but they may fall inside another set of parameters, you can send them into a different bin for, say you have an A customer or B customer, or the B customer wouldn't have as many has as much tight tolerances on the parts. Normally I like to uncheck that box. It really shortens the amount of information you have to put into the parameter dialogues when you're in the software, and I'll point that out towards the end here because I am going to go into some software examples using iInspect Express, and I will point out at that time where that would be. The other thing in this box is it's the third choice down on the upper right hand side where it says Enable Async Acquisition. This system can be used in two modes. Synchronous mode, where the GEVA 300 would receive one trigger, and all cameras, whether it's 1, 2, 3, or 4, would all take their pictures at the same time. Then the outputs that we would access on the PL USB board, we would just monitor, one for pass, one for fail. So if all the cameras pass, we would get the pass output. And if any one of them fails, or any one of the software tools in their individual image areas should fail, you'll get the fail output. If you wanted to use this system as an asynchronous system where you could trigger these cameras individually at different times, yet all of the information still going back to the GEVA 300, we would check that right here where it says Enable Async Acquisition. For the most part, up to this point, the customers that we've sold these to tend to use this in synchronous mode, but I did want to point out that we did have that option. Another utility in there is called iDiscover, and what this does is it's a UDP browser. So when you open this up, it's going to go out and start looking for camera connections on those RJ45 LAN ports on the GEVA 300. The upper right portion of this box right up here is showing the IP connection for the box itself. But below that, this is actually the port, sorry, the particular LAN port on the box. These IP configurations down here in the lower right hand side are for each individual camera. So when you first open this utility from the main screen in the GEVA, what you'll see is you'll have at least one camera hooked to it, but if you were to have 2 or 3 or 4, they would all be listed right here underneath each other. If the camera icon is blue, then the IP scheme for that camera and that particular LAN port are matched, and you'll be able to connect to it. If the camera icon here is red, then there is an IP conflict, and most likely it's going to be in one of the first 3 octets of the IP address. So if we look here in this example, the LAN port that this camera is connected to is 192.168.3.10, and then the camera is 192.168.3.48. So I've got a different address in the 4th octet. Normally when you see a red camera icon over here in the detected cameras, one of the first 3 octets is different than the LAN port, and so it senses that the camera's out there, but we don't have an IP configuration that will allow it to connect to it. So what you can do is just change the IP configuration right down here in this area, hit the apply button, and then you'll see that red camera icon turn blue, And once you have all blue icons over here, then we send them over here to the iInspect camera configurator, and then we just save it, and then we hit close. And at that point, then we're ready to just go ahead and open up iInspect Express, or in some cases Sherlock. The Sherlock camera configurator is a little bit different. So today we're concentrating on iInspect Express. And you'll just open that up, and you'll be able to program each individual camera for setting their exposure times and brightness gains, things like that. And then you can start putting your software tools in there for your inspection. A lot of times in synchronous mode, when you use these cameras or this whole system in a synchronous mode, what we're doing is we're maybe getting multiple views of the same part. Say you want to look at the top and the front and the side. We can put cameras at different angles to inspect different views of the same part. Another scenario would be if you are looking for very small details in your inspection, but your part was somewhat large. Say you had a 36-inch part, but some of the things that you were looking for were only maybe 3/16 of an inch. Putting that whole part in the field of view would really start to degrade your resolution, even if you were to use one of the higher resolution cameras. So in that situation, that's where you might use multiple cameras so that your field of views along the part are smaller, increasing the resolution and your chances of finding what it is you're looking for on that. So those are a couple of the scenarios for synchronous operation, which is the bulk of what we see right now. Asynchronous operation could actually be used where you had 2 or 3 separate lines and you wanted to tie them all back to just one PC, which would be the GEVA 300. Then we would put this in async mode, and you could trigger those cameras individually depending on when targets were underneath them on their particular lines. This is the wiring for sync mode. So we've got 4 cameras in this example. We've got 4 cameras going in the top, and then down here on the bottom side of the board where we interface this to the PLC, we look at the pass-fail outputs over here on the left. We do have some general purpose outputs that maybe you want to utilize in one of the script tools or one of the script editors in the software. Each camera does have its own strobe output. So normally in sync mode, all of the cameras are going to strobe at the same time, but there are certain scenarios where if 2 cameras are kind of pointed in at each other, maybe the light from one would affect the image of the other. And so you could trigger these at slightly several millisecond different time intervals so that the light doesn't really interfere with cameras that might be looking from the other direction. And then you have a bunch of general purpose inputs that you could also use in maybe a script editor to modify some of the logic. This is the wiring for the async mode. So here we would have 4 cameras going in, and they're just color-coded differently here so we can point out what's coming out here at the bottom. So over here on the left side, now we've got a pass-fail for camera 0, a different one for camera 1, 2, and 3, and so forth. Again, all the strobes can be broken out separately and strobe them at different times, especially if targets are showing up at different times under those particular cameras. And we have individual triggers for these cameras as we go in. So again, that would be async mode. The GEVA software is something that I'm going to go into here next and just and show you some of the things that we can do in there. Let me jump over to that right now. So let me get out of this PowerPoint. Clean the screen up here a little bit. When you get the GEVA, you will get the software on a disk also. Even though it's preloaded on the machine, there are some utilities that get loaded that allow you to do some different things with cameras. And this software also works with their smart camera version, the BOA camera, which we're not talking about here today, but it's the same software package. And so one of the things that you get is a emulator, and this one actually says BOA emulator, but it's really an iInspect emulator. So you can have on a separate PC on your notebook, you can have this emulator software, which is what I have here on mine, and we can go in here and emulate different types of camera models. So right now I'm going to go through some examples where I'm going to use a monochrome 640 by 480 camera. Then we can come down here and select where we want to locate those images from. We can have saved bitmaps from your applications in different folders on your PC. And so when you run the emulator, you can point them to the folders that are holding the images that you're interested in. And when we get to that point, we just come down here and we say apply and connect. And we get the actual emulator. I'm going to try and move this box out of my way here. And so here, I've got a couple of examples set up in here right now that I want to run through you so that you can see how the software actually operates. Right now, I'm just going to hit the manual trigger here to get a picture up here. This application was looking at lock barrels. And what they wanted to do is when they manufacture these things, and there's lots of different shapes to these keyholes, obviously, for all the different keys that they can hold. When they're coming down the line, they get to a certain point where they wanted to put the tumblers in. And when they put the tumblers in, they needed the key slot to be pointed straight up at the 12 o'clock position. Well, when these things are coming down the line randomly, and I'll run through a few pictures here for you, these key slots can be in a lot of different orientations. And so what they wanted to do was take a picture of this, have the camera system report the angle of the key slot out to a robot, which would stick a very generic key into this slot, rotate it so that it was at the noon position, and he would get that information from the camera because we would actually report the angle. And so as we go through some of these pictures, I'm reporting the angle down here in a window just below the image area. And so as we go around, it's finding the angle of this key, and it's reporting it out to the robot. One of the aspects of this application was the fact that these keyholes, or these key slots, have a lot of different variety to their shapes. Normally when you look at an application like this, you would think, well, I'll just put a match algorithm on there, and I'll just learn that shape, and wherever it is, I'll just report its angle. Unfortunately, even though DALSA has a very robust pattern match algorithm in the software, some of the keys, as I cycle through these images, you can see they have some varying shapes to them, and a pattern algorithm tool saw those variations and said, hey, this is not the same target that you taught me. And since there's just hundreds of varieties of these shapes, it would be difficult to put a certain number of match tools in there for each one of the shapes that you could see. So I had to find a way to do this in a little more generic sense. So what I did, and I'm going to jump into the tools section of this software. And these over here on the left-hand side of the screen, these are all the software tools that you can apply to your image to do your inspection. And there's a lot of choices in there. Chances are you're only going to use 2 or 3 of them for your particular inspection. But one of the first things I did here is I had to put some locators in here, because as you look at these images as I cycle through, you notice they move left and right a little bit. They can move up and down. So I put an XY locator over here, and an X locator over here, and a Y locator down here to help me find this barrel. Then what I used in here is I looked at all these different shapes. I determined that if I could use a blob tool, and we've got different shapes down here. DALSA calls their blob tool a count tool, but it's really it's a blob tool. And so it's a nice image. I lit this target up with a dark field illuminator, and because I didn't want to see some of the mechanisms that were down in the key slot. And so I got a nice image area. It's black and white. And what I did, I thought a blob tool would work pretty well here. So I went down here into the shape region, and you notice we have a toroid. And so that's what this tool right here is. This is a blob toroid. And so all it's looking is around the edge, inside this donut shape. And what it would do is it would find the dark blob, and when it finds the dark blob, I would have it find the center point of that blob. And so that gave me a reference point for the base of whatever the slot was shaped like. It's always going to have a dark blob there at the bottom. Then I basically did the same thing here in the middle. I just put a blob tool in the middle to find the dark area and find the center of it. And then what I did is I took a pencil tool and I drew it between those 2 center points. And this tool, if we look at the parameter dialog, it really reports angle. And so I really wasn't setting up pass-fail information in here. I just wanted to report the angle, so I put a minimum of 0 and a maximum of 360 because I want it to always pass as long as it finds a key slot, and just report that information out. As I mentioned earlier when we were looking through the camera selector box, I said that you could uncheck the recycle box. You notice here I've got the perfect box in the middle, and then I've got, okay, what's my low end and what's my high end in order for this to be set up for pass or fail if I was using it that way. If the recycle button is enabled, you have an additional box. Instead of these 3, we actually have 5 across here. And it's in between these 2 fails and the perfect, and it's called recycle. If you find that that's somewhat tedious, you have the ability to go turn those boxes off, which you would do in that camera selector dialog. So here, this thing was just reporting the angle. And that's really all I had to do to it. So a couple of locators, find the base of the slot, find the center of the slot, find those centroids, draw a line in between them, and we can go. So if I go to the run mode here, and I move this thing around, you'll see that I'm actually reporting this down here in this inspection status window. And I actually did that with a little script tool in the software. Might as well show that now. I actually just came into the script editor and just put a little code in here. So I'm looking at the slope tool, which the angle tool or the pencil tool I named slope. And I'm putting some text in there. This is just text that says key angle equals, and then I put the data over here. And if it was less than 180, I made the text dark green. And if it was less than or equal to 180, it was dark green. And if it wasn't that, it was dark red. So I was just splitting that up between the 9 and 3 o'clock positions. In a camera, the 3 o'clock position is 0 degrees. 9 o'clock would be 180. So I just put a little script in there to report that into this window. And so as I cycle through this application, you can see that it's reporting the angle of this key slot regardless of what the slot is actually shaped like. And this is just one example of the hundreds and hundreds that we've looked at over the years. I thought this one was a unique application, and it did a really good job solving that. Let's go to another one. So I'm going to go back to the main screen, and I will select a different application that I have stored. Even though this is an emulator, it does store different programs that you save in here so that you can use them at your PC. And now I have to go in and select a different set of pictures for the second application. And this was an OCR application. And let me take one picture. And so this part had a serial number on it that they wanted to read, and they wanted to make sure too that it was printed correctly. But they also wanted to read that and send it out. And so it's on a curve, and OCR can be challenging enough when it's a straight line, and now we've got it at an angle. And so we were able to put an annulus, the software, and iInspect Express has in the OCR tool an annulus tool. So I was able to create a curved tool here, which then straightens it out. Let me go into the tool sections of this, and we'll go to the OCR, and I'll pop open that dialog. And if we go into the editor, you can see that here, you can see that even though that was on a curve, it straightens those things out. Now, an OCR tool is just a group of pattern algorithms, and so you tell it that this is a 2 and 0 and 8 and so forth, and it remembers those patterns, and that's what it's looking for. And so as I go through this one, you can see, now this one failed because the 0 right after the 2 was misformed. And so that's a defect, and they wanted to flag those things. Over here in the center of the screen, though, I had to find a locator because this part was going to rotate. So now I'm dealing with OCR that's on a curve, and I was dealing with a part that didn't actually have stability, or was it fixtured when I wanted to look at that. So what I did is I put a pattern algorithm in here, and I taught what this shape right here looks like, which was very unique to the part. There's no other area on here that shape shows up, and so I actually made a very good locator. And so as we go through these pictures, you can see that it's moving the OCR tool to stay over the area where that serial number was formed. And of course here we've got a problem with the 6 at the end of it, and so we failed it because it wasn't in there completely. And so that's that application. I could sit here and show applications all day. Unfortunately, these webinars have a limited amount of time, And the points I wanted to make across to you guys today was, you know, this system's out. It's been out about a year. We've sold a number of them. I have one here in my lab, and I've been using it quite a bit over the past 6 to 8 months. And I found it to be a very reliable system. I haven't had any issues with it. It's very fast compared to a smart camera like the BOA cameras that Teledyne DALSA sells. This is a very fast system. Inspection times in the the 15 to 20 range, regardless of what tools I have on there. I've tested this with some very large pattern algorithm tools, and they're very fast because the processor in there is much faster. On a side note, I want to mention I just discovered this the other day. Teledyne DALSA, which makes the BOA cameras, they're coming out with a new series of BOA cameras called the BOA 200, which are going to be about 4 to 5 times faster than the current BOA models that are out. So for any applications where you guys may have used BOAs, if you've got some high-speed applications, we are going to have a solution here. They should start shipping here towards the end of August, early September. So we just have another option from Teledyne DALSA for high-speed applications. And with that, I'm going to end this seminar. Appreciate everyone attending today. I hope you found this information useful. I am recording it, so it will be on CNE's website if you need to look at it in the future to review it, or if you want to show it to somebody else, that's where it will be. And again, I want to thank everybody for showing up today. We appreciate it, and have a good day.